So imagine you ask a chef, what's for dinner?
Right.
And instead of handing you a menu, they just hand you a crumpled grocery receipt.
Right. Just a list of ingredients.
Exactly. You don't want a time-stamped list of flour, butter, and, a raw cut of meat. You want to know you're getting beef Wellington.
Yeah, you want to know the actual result, not the shopping trip.
But handing over the grocery receipt is exactly what most software developers do to us. Like every single time our apps update.
Oh, absolutely.
You click to see what changed, hoping to understand the new features, and you just get hit with that meaningless phrase, bug fixes and improvements. Or worse, an impenetrable wall of technical gibberish.
Which is incredibly frustrating. It leaves you, the user, completely in the dark about what just happened to the tool you use every day.
Well, today we are doing a deep dive into a 2026 presentation by a developer who goes by the handle at Look036. It's titled GitHub Release Notes Rewriting, From Commit Dumps to Narrative Notes.
It's a fascinating slide deck, really.
Yeah, it documents how this developer used a very specific workflow to completely transform the release notes of 24 different C++ projects. And get this, they executed this massive overhaul in just 30 minutes.
Which is incredibly fast. But honestly, the speed is just a byproduct. The real value here is the underlying mechanism.
Right, how they actually pulled it off.
Exactly. Our mission today is to explore how shifting our focus from the effort of doing work to the actual effect of that work totally transforms communication.
And it doesn't just help human readers, right?
No, not at all. As we'll see, this shift completely unlocks the potential of AI coding agents to actually understand complex systems.
Okay, whether you are managing a team and you're tired of getting status updates that are just endless lists of tasks, or you dabble in code, or you're just fascinated by how AI parses human systems, you are going to get a masterclass in structuring information today.
We should probably start by looking at why the default system is broken.
Yeah, let's talk about the mechanical failure there. So GitHub is the platform where millions of developers host their code, and they have this auto-generated option for release notes called What's Changed.
Right. And when a developer uses that default option, the platform simply scrapes the commit subjects and just pastes them verbatim into a flat list.
And to understand why that fails, you kind of have to know what a commit subject actually is.
Yeah, so when a developer makes a change to a piece of software and saves it, which is called committing the code, they leave a brief note for themselves.
Like fixed typo or updated dependency or something.
Exactly, or, refactored user login. It's just a breadcrumb for the developer.
And the slide deck we're looking at shows a perfect example of why compiling these breadcrumbs is a disaster for the end user.
Yeah.
One release note they showed featured 18 different commit subjects just stacked on top of each other.
18 of them. Just a robotic list of highly specific, disconnected microtasks.
Zero hierarchy. Zero narrative connecting them.
Because a commit log is literally just a chronological diary of the developer's effort. It's the grocery receipt. It documents the sequence of events, but it doesn't tell you the meal.
Right. And the author of this presentation introduces this core philosophy that drives the whole transformation. They say, commit messages describe effort, but release notes should describe effect.
Which perfectly maps to your restaurant analogy. The user eating the meal doesn't care what time you bought the butter. They care how the meal tastes.
And this wasn't just some philosophical annoyance for the author. It was an operational nightmare. I mean, they were maintaining 24 separate C++ repositories, all releasing on a similar schedule.
Yeah, so this wall of unreadable text was multiplying across dozens of projects.
But, a problem that scales is also an opportunity for a solution that scales, right?
That's exactly it. If they could engineer a framework that extracts the effect from the effort, they could apply it uniformly across the board.
Which leads us to the solution. Since the commit messages are the wrong source of truth, they had to abandon them entirely.
Right. They designed a new 4-step workflow. Diff, title, notes, and edit.
Let's focus heavily on that first step, the diff, because really everything else flows from it.
Yeah, the diff is the secret sauce here.
Now, for a lot of people, version control terminology can sound like a foreign language, but a diff is conceptually very simple.
Think of it as a forensic accounting ledger. A diff, which is short for difference, is the raw mathematical reality of what changed between the old version of the software and the new version.
It doesn't care what the developer wrote in their diary.
Not at all. It simply shows exactly which lines of code were added, in green, and which lines were deleted, in red.
The presentation highlights a project called LDSCPP to show why looking at the ledger is better than reading the diary.
Right, because if you read the developer's commits for that update, you get 18 random bullet points.
But when you look at the raw diff, the math tells a totally different story. It revealed that 34 files were modified. Specifically, 565 lines of code were added and 1,812 lines of code were removed.
And that's a massive clue. When you see a huge subtraction of code across dozens of files, accompanied by a smaller addition, that usually indicates consolidation.
So the raw math pointed to a massive architectural shift.
Exactly. The underlying theme of all that effort was a unified single-root CMake build.
We'll touch on what CMake is in a minute, but notice the contrast there. Thousands of lines of code changed across 34 files. That is a massive amount of effort.
Huge effort.
But the effect boils down to a 6-word sentence.
And once you extract that core theme from the diff, you can actually implement the author's new style guide.
Right, let's talk about that style guide. The first rule changes the title of the release. Previously, titles were just arbitrary tags like, V1.2.4.
Which is just a serial number. It offers literally no context.
0.
But the new framework demands that the version number is immediately followed by the core theme derived from the diff. So the title becomes V1.2.4, Unified Single Root CMake Build.
So the reader instantly knows the primary impact of the update before their eyes even scan down the page.
Exactly. It's front-loaded.
Then we get to the actual notes themselves. And this is where the author makes a very controversial choice for the enterprise software world.
The emojis.
Yes, they mandate an emoji category system to organize the impact. And look, I have to push back on this on behalf of anyone who works in a corporate engineering environment.
Fair enough. Go ahead.
If I'm a senior engineer reviewing a highly technical, dense math library, seeing a little caterpillar bug or a construction crane feels incredibly frivolous.
I get that.
Why not just use strict text tags? A bracketed word like performance or fix is universally readable, it looks professional, and it doesn't rely on a device knowing how to render a specific Unicode emoji.
I hear that critique a lot, actually, but it usually stems from a misunderstanding of how the human brain processes visual information.
Okay, how so?
Using emojis in dense technical documentation is not about making it look cute or trendy. It's a calculated technique to reduce cognitive load. When your eyes scan a page of text, even capitalized bracketed text like performance, your brain still has to engage its language centers to read and categorize those letters.
Right, it takes processing power.
Exactly. It takes effort. But an emoji bypasses that entirely. It acts as a pure visual anchor. The brain processes a lightning bolt as a symbol of speed almost instantly without reading.
Okay, I see what you mean. And the style guide applies strict rules to these symbols, right?
Very strict. A construction crane always means the build system. A caterpillar is for fixes. A lightning bolt is performance.
A recycling symbol is refactoring.
Yes. A test tube is for tests. An open book is documentation. A wrench is maintenance. And a cardboard box is for dependencies.
So if a user only cares about whether an update will make their software run faster, they just drag their eyes down the page looking for a yellow lightning bolt.
Yeah, and if it's missing, they just stop reading and move on with their day.
Wow. Okay, I see the utility.
And that leads to the crucial second rule of the style guide. Only the categories that are actually present in the diff will appear in the release notes.
So you never have empty categories taking up space.
Never. It turns a flat list of 18 technical chores into a highly organized, instantly scannable hierarchy.
That makes total sense. And the final piece of the style guide dictates how the narrative bullets under those emojis are written.
Right. They must use concrete names, state the real effects, and most importantly, the entire release note must end with a changelog link.
So if an auditor or a deeply curious user really wants to see the raw code changes, the link is right there at the bottom.
Exactly. You provide the menu up front, but you keep the grocery receipt filed in the back office just in case.
I love that. This framework is incredibly elegant. But knowing how to format a perfect release note is really only half the battle.
Oh, for sure. Applying it is the hard part.
Right. Going through 24 different C++ repositories, forensically analyzing thousands of lines of raw diffs, categorizing the changes, and rewriting them into narrative bullets. I mean, that would take a human developer days of tedious work.
Which is exactly why the author didn't use humans.
This is the crazy part.
Yeah. They orchestrated 8 background AI coding agents to execute this overhaul in parallel.
So they assigned 2 to 3 repositories to each agent.
Yes, and because the agents could run simultaneously, the entire process across all 24 projects finished in just 6 to 10 minutes per agent.
Okay, wait, let's stop and examine the mechanics here. Because injecting AI into a highly technical code base requires heavy scrutiny.
Absolutely, it's risky.
We're talking about an AI reading thousands of lines of complex C++ math and configuration files, and then trusting it to summarize what happened. AI models are notoriously eager to please, right?
Very true.
Which often leads to hallucinations. If an AI agent sees a change in a math function, what stops it from confidently inventing a brand new feature that doesn't actually exist in the software?
Yeah.
Like, how do you prevent it from lying to the users?
Well, the short answer is you don't trust the AI at all.
You don't.
Not even a little. You use deterministic verification. The author achieved this using a specific command line tool called GH_release_view.
Okay, so it acts like a bouncer.
Yeah, a rigid binary filter. This tool doesn't read the AI's mind, nor does it ask the AI if it's telling the truth.
Explain how that filter operates in practice, then.
So when the AI agent finishes analyzing the diff and drafts the new notes, it doesn't just hit publish. It outputs the draft in a strictly formatted structure.
Okay.
The command line tool then takes that output and validates it against the actual state of the repository. It checks if the version tag the AI mentioned actually exists in the code. It verifies that any links generated actually resolve to real, live pages.
So if the AI hallucinates a file path or formats the markdown incorrectly,
the command line tool throws a red light and the whole process fails.
Wow.
The AI is forced to try again or flag for human intervention. The guardrails are entirely structural.
That makes perfect sense. The tool forces the AI's output to map cleanly back to reality. And because all 8 agents were operating under this strict 4-step workflow, the results across the 24 projects were remarkably insightful.
They really were.
Like when the author looked at the entire August batch of updates, a massive overarching theme emerged across independent repositories with names like CKPTT and CPP, CSDCPP, and DGraphics Fast.
The AI correctly identified that all these different libraries were undergoing the exact same foundational shift.
The CMake unification we touched on earlier.
Exactly.
And for those unfamiliar with C++, CMake is essentially the foundational plumbing for how software is assembled and built. Doing a single root unification across 24 different projects is like a city standardizing the electrical grid across 24 different neighborhoods.
It is a massive structural overhaul.
And it would have been incredibly easy for an AI to just stamp CMake unification on every single release and call it a day.
Oh, completely. But the presentation highlights several case studies that prove the AI was actually weighing the specific nuances of each project's diff.
The adaptation is the most impressive part to me. Take a project called Core Solver CPP. These are dense math libraries.
Right.
The AI analyzed the diff and titled the release LSQ and MLE solver benchmarks.
Which stands for least squares and maximum likelihood estimation for the math nerds out there.
Exactly. The AI noted that background dependencies were updated, but it recognized that the benchmark tests for those specific math solvers were the most critical piece of information for the end user.
So it elevated the benchmarks to the headline.
Yes. And we see an even better example of that contextual judgment in a repository called Fraction Simple.
Oh, this is a great one.
Yeah, it's a tiny header-only repository, a very small code base. The raw diff showed a bug fix in how mixed integer arithmetic was handled.
Now, in a massive sprawling project, a single math bug fix might just be a minor footnote.
Exactly. But the AI recognized the scale of the repository. It knew that in a code base, this small, fixing mixed integer arithmetic and refactoring the greatest common divisor logic was the entire point of the release.
So the bug fix became the title, categorized with a little caterpillar emoji.
Yep. Then you look at Sphere NCPP. The AI drafted the title, Vector Indexed PP Memoization Caches.
And it slapped the lightning bolt emoji on it.
Because it recognized pure performance.
Yeah.
Memoization caches are all about storing previously calculated results to speed up future calculations.
Right. And the AI saw that there were updates to the documentation and some code cleanup, but it correctly deduced that a massive speed upgrade overrides a document cleanup every single time.
My favorite example from the slide deck, though, is LMI Solver CPP.
The documentation one.
Yeah. The forensic ledger of the diff revealed something unique. This library had never had a readm file before. The AI caught the addition. The title it generated was README, Doxygen Docs, and installed package verification, accompanied by the open book emoji.
And Doxygen is a tool that automatically generates documentation directly from comments in the code.
Generating the first ever user manual for a complex library is a massive upgrade for the user experience. The AI prioritized the new manual over any minor code tweaks.
Which proves that the AI isn't just reading the code, it is synthesizing the context.
It really is. Which brings us to the meta point of the entire presentation.
Yes, the big picture.
We spent this time discussing how an emoji-driven, theme-focused style guide lowers cognitive load for human readers. But the structural reason this workflow is so effective is because it caters perfectly to the constraints of AI coding agents.
Let's expand on that, because if an AI is an auditor, and it needs to understand the health of a company, it shouldn't be reading the CEO's internal memos.
No, it needs to read the ledger.
Exactly. Human commit messages are noisy, developers use shorthand, they make inside jokes, they forget to mention crucial changes entirely. To an AI, human commit messages are basically unreliable data.
Right. If you ask an AI to write release notes based on commit messages, it's like asking a student to write a book report by only reading the back cover.
That is a perfect analogy.
They might get the general vibe of the book, but they'll miss all the actual chapters. And they'll probably fill in the gaps with assumptions, which leads to hallucinations.
But this workflow forces the student to read the actual chapters. The author actually lists 7 distinct ways this specific pattern empowers AI agents.
Let's hear them.
First, it's a reusable skill. The agent doesn't need to learn a new process for every repository. The diff to narrative pattern applies universally.
Makes sense.
Second, it is highly context efficient. The AI only has to analyze the lines that actually changed rather than reading the entire massive code base.
Which saves immense processing power and keeps the AI focused.
Exactly. Third is the deterministic verdict we discussed. The pass-or-fail feedback loop from the command line tool gives the AI firm boundaries.
Right, the bouncer.
Yep. Fourth is theme clarity. By requiring the AI to write a short title, you're forcing the model to synthesize the information. It can't just list facts. It has to answer the question, what is the primary impact?
It has to have an opinion, almost.
Yeah. Fifth, the process is parallelizable. Because the workflow is stateless and independent, you can unleash 8 or 80 agents simultaneously without them stepping on each other's toes.
That's how they did 24 repos in 30 minutes.
Exactly. Sixth is full traceability. By always ending with a link to the original changelog, the AI's output is permanently tethered to the source data. It allows humans to audit the auditor.
Trust but verify.
Always. And seventh, it ensures a consistent voice. The strict emoji categories and narrative rules guarantee that no matter which of the 8 agents drafted the notes, the final output looks like it came from a single organized intelligence.
But there is a massive caveat to all of this, and the author makes this very clear. The quality of the final release notes has a hard ceiling, and that ceiling is set entirely by the diff analysis.
But this is the danger of what the author calls lazy agents.
Right.
If a developer sets up this workflow but prompts the AI poorly, like if they allow the AI to bypass the git diff and just summarize the text of the commit subjects, the entire system falls apart.
The student goes back to reading the back cover.
Exactly. The AI will output perfectly formatted, emoji-categorized notes that are completely useless. They'll just be polite, synthesized versions of the grocery receipt.
Which defeats the whole purpose.
Completely. AI thrives on predictable, verifiable routines. The tedious, repetitive work of scanning 24 raw code changes is precisely what AI agents excel at, provided the framework strictly enforces the raw data analysis first.
You know, if you're listening to this and you manage a team, whether that team writes software or builds marketing campaigns or manages supply chains, think about how often your team reports their progress.
That's a great point.
Do they report their effort, detailing the hours they spent and the emails they sent? Or do they report their effect, detailing the value they actually delivered?
The philosophy of moving from effort to effect completely shifts how an organization communicates. It forces clarity.
It really does. And remarkably, from a technical perspective, this developer took a sprawling, unreadable mess across 24 different projects and solved it by enforcing a simple philosophy and utilizing one command line tool.
It's a stunning example of engineering a communication workflow.
It proves that the bottleneck is rarely the technology, right?
No, it's usually how we structure the information we feed into the technology.
I want to leave you with something to consider as you go about your rent. We have just seen how an AI agent can successfully analyze raw, dense, mathematically complex C++ code changes and reliably translate that impenetrable effort into a perfectly formatted, human-readable narrative of effect.
The AI basically acts as the ultimate translator between complex execution and simple understanding.
It bridges the gap between the creator and the consumer. So where else in your life is that translation desperately needed? Like, could we apply this exact diff-to-narrative framework to dense legal contracts, summarizing the actual impact of the clauses instead of just listing the legal jargon?
Oh, that would be amazing.
Right. What about medical records? Translating raw lab results into a narrative of patient health. Or financial audits.
There's so many applications.
Where else in your daily life or your business are people handing you a crumpled grocery receipt when all you really need is the menu?
Once you start looking for that disconnect, you realize how much of our daily communication is just a commit dump.
You really do. Keep an eye out for the ledgers hidden underneath the diaries. Thank you for exploring this framework with us, and we will see you next time.